After we are comfortable with synthetic division, we go for remainder theorem and factor theorem. Factor theorem is just a conclusion of remainder theorem. So let us talk about remainder theorem at first. Let us suppose we have a polynomial function f of x and let's divide it by x minus a, or linear function. Then we will certainly get a quotient function plus the remainder can be written as r over x minus a. You can simply think this division algorithm as writing in this way. Let's suppose if you are dividing 14 by 3, 3 times 4 is 12 plus 2 over 3. So we are writing in this way since 4 is the quotient. So if you are dividing 14 by 3, then 4 is the quotient and 2 is the remainder, and that's 3 is the divisor. Okay. Then you can write this as f of x equals to qx times x minus a plus r. This is another way to write down the division algorithm. Let us suppose x equals to a. Let us plug in x equals to a. Then since we have divided the function, the polynomial function, by x minus a, so we are getting this kind of structure of f of x. Then if we plug in x equals to a, then this would be f of a equals to qx times 0 plus r. Okay. Therefore, I can write remainder equals to functional value at a. So this is the idea about remainder theorem. So if you divide any polynomial function by x minus a, then the remainder can be found out by just plugging in x equals to a in the function. If f of x is divided by x minus a, then the remainder of this division is r equals to f of a. So that's the idea of remainder theorem. Now how about factor theorem? Factor theorem means x minus a divides f of x exactly if the remainder is 0, right? So the factor theorem is, okay, x minus a is a factor of f of x if and only if x equals to a is a 0 of f of x. Okay, you can just plug in x equals to a in the polynomial, and if the remainder is 0, then x minus a is a factor of f of x. So let us use this factor theorem and try to see if any number is a 0 of a polynomial or not. Let's take an example. F of x equals to x cubed minus 6x squared minus x plus 30, and we would like to see whether these two numbers are zeros of this polynomial or not. So to do that, we would just go for remainder theorem and factor theorem, okay, combination of those. So let us just simply plug in -2 in here to see whether this number is a 0 of this polynomial or not. So that would be f of -2 equals, let us calculate that. So that becomes -2 whole cube is -8 minus 6 times -2 square means that's 4, 24, minus -2 is +2, okay, -2 is +2 plus 30. So that is -32, and this is also -32, +32, so that becomes 0. So thus the remainder is 0. Whenever we divide this polynomial by x equals to -2, which is x plus 2, that is 0. That means yes, it is a factor. Yes, x equals to -2 is a 0 of this polynomial, or x plus 2 is a factor. Let's go for b equals to 1. Okay, so let us plug in 1 in the given function. So f of 1 equals to 1 cube minus 6 times 1 square minus 1 plus 30. So which is 1 minus 6 minus 1 plus 30. So that is 1 and 1 cancels out. 30 minus 6 is 24, which is not equal to 0. So that means we will get a remainder whenever we divide the entire polynomial by x minus 1. Okay, so x minus 1 is not a factor. So this is the way how you use remainder theorem or remainder theorem and factor theorem in combination to figure out whether a number is a zero of a polynomial or x minus a is a factor.